Hello everyone, let's solve leetcode 746 minimum cost climbing stairs today. This is an easy problem, but it's really a good example to demonstrate recursion and dynamic programming method. So first let's read the problem. We are given an integer array of cost where the ith element represents the cost to step on the ith stairs. So once we pay the cost, we can either go one step or two steps. And we can start from index number 0 and number 1. So finally we want to find out the minimum cost to reach the top of the floor. So the best way to understand this problem is by looking at the example and visualize it. So here I have a simple chart for this example. So we have such a stair where we need to pay 10 for the 0 step, 15 for the first step, and 20 for the second step. So here, as you can see, we can simulate how we can go through those stairs. So we can either start from stairs number 0 and we need to pay 10, and then we are at number 1, one step. 15 we need to pay, and then we can go one step further to number 2, and then we need to pay 20. Finally we can reach the top. So as you can see, the cost for this route is 45. But here we have another option. At the first step, we can also choose to pay 15, but we can go 2 steps further. So then we are directly at the top. So here the cost for this route is only 25. So similarly, we can choose to go 2 steps directly from index number 0, and we can reach the second stair, and then we can go one step further to the top. So this route, our cost would be 30. And here actually we have another route where we can go 2 steps further from step number 2. But as you can see here, we are out of bound, so this route is not the option. And similarly, if we start from index number 1, we can go 1 step each time, and to reach the top, the cost would be 35, and we can go 2 steps directly. The cost would be 15. So here we also have the option to go 2 steps here, and here we are out of bound. So basically, this is a very intuitive recursion approach, and first let's code it up. So here I will create a function which will return the integer. Let's call it whatever, and we would like to pass in this vector by reference, and we would like to know like which stair we are at right now, so I would pass another integer here. So first let's think about our base case. If we reach the top, which means if we are at the size of this vector, here we don't need to pay anything else to go further, and we are basically done. So we will return 0 here. And how about the other case where we are out of bound? For those out of bound routes, like here, we would never finish it. It's not a possible solution. So I would like to return like a max value, max cost for this route, so that it will never be chosen. And I would return I just want to make sure like I would just exceed the maximum cost of these constraints. So then we can think about our recursion part. So starting from each stair, we can either go 1 step or 2 steps, so which means we have 2 options and we need 2 integers. The first one would be our current cost of our current stair plus the cost to start from the next stair. So here I would go for stair plus 1, and similarly we need the second integer. Here we can add up our current cost and the cost to start from the plus 2 stairs. So finally, basically, we just want to return the minimum of cost 1 and cost 2, as we want to find out like the cost of the minimum cost to start from stair number 2 and the minimum cost to start from stair number 1 and stair number 0. So let's return the minimum cost of cost 1 and cost 2. So basically we are done for this function, and we can call it from our main function. Here we would just return this the minimum value to start from index number 0 and the minimum cost to start from index number 1. So basically I think we are done. Let's see whether our solution is correct. Time limit exceed. Okay, so here as you can see, like I intentionally copied the longest test case here. So you will see, like in this solution we need to calculate the cost to pass step number 1, number 2 repetitively a lot of times. So this makes our complexity extremely high, which means we couldn't pass this long test case. So what we can do is we can try to memorize the minimum cost we need to pay to start from each certain stairs to the top, and so that if we meet the stairs a second time, we can return this cost directly without any calculation. So what I will do is I will use a hash map. Integer. I will use a hash map to memorize those costs. You can also use a vector, it doesn't matter. So here I would like to remember our cost. So memo 0, and similarly I will here, and here I would calculate this minimum value and place it into our memo. Their result. Yeah. Oh, sorry, I think I made some typo here. This should be there. And finally we can return our result. So then we can code up our logic. If we reach a stair where we already calculated it, so we can check whether we have already reached this stair, and if we have already reached certain stairs, we can just return, right? So this should be our solution. And now let's run it again. So please, we have a bug here in place. Sorry, I made a typo here. It should be LA, not AL, in place, and also here. This was correct. Okay, let's run it again. Great, we passed the 2 test case, and if we submit it, I think we will pass. Great. As you can see, our performance is not so good here, so can we do better? So actually the answer is yes. We can simply code it up and change this logic into dynamic programming. The logic would be very similar, so I will just comment it out and leave it as the reference. So what I will do is, first I will need to know how to initialize our DP arrays. So I will calculate the size plus 2, because here, as you can see, we will now initialize our base case. The first, this one would be the out of bound, and the next one, this one would be our top. So this cost is 0, and then for each stairs we would just need to calculate like this. So I plus 3 from I plus 3 to 0, and for each step we just need to do this calculation. We want to calculate the current cost plus the minimum value of the cost to start from next stair and the over next stair. So here this can be written as is equals to cost number I plus minimum of dp I plus 1 and dp I plus 2. Okay. So we are done for our calculation, and now we just need to return the minimum of dp0 and dp1, as we can either start from index number 0 and index number 1. So now we will, what the hell is this? dp, no dp, okay, sorry, I forgot to initialize our dp array. So dpn here. So here you can also use a vector or whatever data structure you like, but I will just use a teacher here, and we have another problem. Turn I plus 1, this looks correct, so what happened? Okay, let's see this test case. Too much. Cost of number I. Oh, sorry, I made a super stupid mistake here. As you can see here, this shouldn't be n-3, instead it should be n-3. I reset our test cases, and now let's run it again. Yeah, it works. So now we can submit. Yeah, it works, and as you can see, it's a pretty efficient algorithm. So as you can see here in our dynamic programming algorithm, we are only iterating through the whole vector once, so our space complexity will be O of n, and as we are using like a integer array of size of n, our memory complexity will also be O of n. So this is our solution, and you will find the code in the description below. Thank you for watching, and see you